You ever been on a project that just completely goes off the rails? You know the feeling. Deadlines are flying by, the budget is totally busted, and everyone is just frustrated. It's this universal headache, right? Doesn't matter if you're building a skyscraper or a new app. And it turns out there's a shockingly common reason for all that chaos. So let's dig in.
There it is, 70%. That is a staggering number. 70% of projects fail. And the main culprit, it's not a lack of talent, it's not a lack of effort, it's bad planning. I mean, just let that sink in for a second. For every 10 projects that kick off, full of excitement and promise, 7 of them are pretty much destined to fall short or just fail outright. That's wild. You've heard this a million times, I'm sure. But that 70% statistic, it proves this old saying is just as true today as it was centuries ago. It's not just some nice, catchy phrase. It's basically the first law of project management. Okay, but here's the good news. This crazy high failure rate, it's not some unbreakable law of the universe. It's a problem, and problems have solutions. You can absolutely tame the chaos of a poorly planned project, but, and this is key, you can't use a one-size-fits-all approach. You need the right tools for the job. And that's exactly what we're going to do today. Think of us as opening up a project manager's specialized toolbox. But inside, you're not going to find hammers and wrenches. You're going to find these incredibly powerful planning techniques. Each one is a specialized instrument, and knowing when to use which tool, well, that's the real secret. That's how you flip that 70% failure rate right on its head.
All right, first up, let's talk about projects that move in a straight line. And I mean that literally. We're talking highways, railways, pipelines, stuff like that. For these, you need a very special kind of map.
And that map is called a time chainage diagram. It is such a brilliant way to see what's going on. On one axis, you've got time. On the other, physical distance. So an activity, like, say, paving a road, shows up as a diagonal line. And the steeper that line is, the faster your crew is moving. It's so simple but so powerful. A schedule and a map all rolled into one.
Now, here's where this tool gets really clever. It shows you problems that other charts, like a standard Gantt chart, just can't see. Imagine you're building a 50-kilometer-long motorway. A normal chart won't tell you if your earthworks crew is about to literally run into the crew building a bridge. But on this diagram, you can see their work paths getting closer and closer. It's like a traffic map for your project. You can spot that physical traffic jam weeks ahead of time and actually do something about it.
So, what's the bottom line? For any project that moves along a line, this thing's ability to spot those physical clashes is absolutely unbeatable. But, and it's a big but, if you try to use this to plan a software project, you're using completely the wrong tool for the job. And it does take a bit more setup on the front end.
Okay, so that's for projects that stretch out over a long distance. But what if your project doesn't go out, but goes up? Picture a 40-story apartment building where you're basically doing the same thing over and over again, just on a different floor. For that kind of work, you need a tool that understands rhythm.
The first of these rhythm tools is called line of balance. And the goal here is pretty simple. You want to create a smooth, continuous production line. You want your framers, your plumbers, your electricians to just flow through the project like a well-oiled machine. No one's waiting around and nobody's getting in anyone else's way. It's all about balancing the pace of every single trade.
The upside? It's huge. You get this beautiful, efficient workflow where everything just hums along. The trade-off, though, is that to get that perfect harmony, the whole project might take just a little bit longer than if you just had everyone rush in chaotically. And of course, if your tasks aren't repetitive, this tool is pretty much useless. Now, a close cousin to line of balance is takt time planning. Takt is actually a German word. It means a beat or a rhythm, like in music. And that's the perfect way to think about it. The idea is you give every single trade the exact same amount of time, the takt, to get their job done in a specific area before they move on. It creates this incredibly predictable, almost metronome-like pulse for the entire project. And the payoff for that is amazing predictability, which cuts down on a ton of waste. But here's the catch. It demands so much careful, meticulous planning before you even start. You have to get that rhythm perfect on paper first. And just like line of balance, that focus on a steady pace over just raw speed can sometimes add a bit to the final timeline. So far we've covered projects that are linear and projects that are repetitive. But what about the messy ones? The ones where everything is connected in this complex web of dependencies? Or what about projects where you don't even know what the final goal is when you start? For that, we've got to pull out a totally different set of tools.
This is where the network diagram comes in. Really, it's all about answering one simple question. What has to be finished before something else can even start? It's basically a dependency map. It lays out the critical chain of events, like a GPS for your project, that shows you every single required turn. Now, there are two main flavors of this. The older style, activity on arrow, is a little rigid. But the modern standard, the one you'll see in most project software today, is activity on node. And it's way more flexible, because it understands that projects are more complex than just finish this, then start that. For example, maybe you can start painting the walls once the drywall installation is just halfway done. AON can handle that kind of complex, real-world logic. Okay, now let's make a big pivot to a tool that was born in the super fast-paced world of software development, where plans are constantly changing. This is velocity charting. This isn't about trying to plan every little task months in advance. Nope. It's about measuring a team's actual proven capacity. You don't guess what they can do. You look at the data and see what they actually did in the last work cycle or sprint. So what does that look like in practice? Well, in their first 2-week sprint, this team here got 15 points of work done, then 18 in the next one, and 22 in the third. See the pattern? After just a few sprints, an average starts to emerge, and now you have a reliable, data-driven forecast of how much work this team can handle. No more guesswork, no more wishful thinking. And this is where it becomes a superpower. It's a diagnostic tool. Suddenly, in Sprint 5, performance drops to just 12 points. The chart doesn't have an opinion, it just shows you the facts. It immediately throws up a red flag. Now, it doesn't tell you why there's a problem, but it forces the team to ask the right questions. Was something way harder than we thought? Did we run into technical problems? It's like an early warning system that's based on reality, not on a plan someone made up 3 months ago.
So we've got all these incredible tools in our toolbox. But, just like a master craftsman, a great project manager knows that just having the tools is only half the battle. The real skill, the real art, is knowing exactly which one to pick up for the task at hand. And this isn't just some academic theory. You see this specialization out in the real world every day. Of course, civil engineers building a highway are going to love time change diagrams. It speaks their language. It's no surprise that architects, who think in terms of repeating floors, are masters of tact planning. And software engineers, who live and breathe in these iterative sprints, absolutely rely on velocity charting. It's their North Star. Which brings us right back to where we started. That scary 70% failure rate, it's not our destiny, it's just a symptom. A symptom of using the wrong blueprint for the job, or maybe no blueprint at all. These tools we've looked at, these are the proven blueprints for success.
So the key takeaway here isn't to find one magic bullet for planning. That doesn't exist. It's about becoming a kind of project diagnostician. First, you have to really understand the unique DNA of your project. Is it linear? Is it repetitive? Is it a complex web? And only then, only after you've made that diagnosis, do you reach into the toolbox and select the precision instrument built for that exact challenge. So as we wrap this up, I'll just leave you with this one thought. The next time you're standing there at the very beginning of a new project and you're staring down that 70% statistic, just take a moment, open up your toolbox. The tools you need to beat those odds, they're right there. The only question is, which one will you choose?